All right, time to take this another step. Remember, we played with the a value that is up front here, but what happens when we add another value out to a parabola like this? I'm curious. The a value, of course, made it wide and narrow, happy parabola, sad parabola, but what happens if I just add a number to this? Well, let's think about this for a second here. Let's see exactly what happens. I'm going to use my x, y equals to x squared right here again, but now I'm going to use the value of 0. And if you remember, at 0, we always started right here. The original was looking very much like this at the origin, and that would be its vertex here. But watch what happens when I do this. Watch what happens when I go y equals to x squared and I add, let's say, 3 to it. This 0 now becomes 3. So I'm no longer starting at the 0, 0 mark. I'm actually starting up here at 1, 2, 3. But if you think about it, I haven't changed my a value here. That a value is still a 1. So I haven't made it wider or narrower or anything. I've kept it exactly the same. So all I did is shift this thing upwards 3 units. Let's prove it. Let's go to our calculator here and find out if this is true. So here's my calculator. Let's put in the original. We always say make sure you've got the original in there. X squared, it's going to be in blue. Now we're going to change this. We're going to say, okay, here's my x squared, and now I'm going to add 3 to it. So 3 outside, just like what we had here. All right, graph it. Here comes our x squared, and lo and behold, look at that. I've moved that up like this. So what I did here is I expanded my calculator out so I can actually see this, but I want to show you something really, really important. And the thing that I want to show you is the fact that this did not get wider or narrower. We did not change the a parameter, and I want to prove this to you by taking this guy here and just coloring it in as best I can with my coffee shakes. There it is, in green, but I want to show you this. Watch, I'm going to try to pick it up here. There it is. I'm going to take this guy and I'm going to move it down, and look how it is an exact match to this guy. Look at that. So that tells you that the original graph is exactly the same. It's not wider, it's not narrower, it's exactly the same. Look, I'll move it again. There's that one, and there's that one. So we have not changed the wideness or narrowness. All we did is we shifted it up. So I got a question for you, and you could probably answer this right now. What happens if this was a -5? Well, look, here, 0 squared is 0. Subtract 5, look, there's our new vertex at -5. So in fact, this guy, the original, will still be here, right here, bada-boom, right? There's our original, but now we're going to be at 1, 2, 3, 4, 5, way down here, and looking upwards like this. So what I want to do is I want to prove that by looking at the calculator again. So let me get rid of this, okay, delete, gone. Go back to here, y equals 2. Let's put our value in, x squared -5. Let's graph it and see if our prediction comes true. And sure enough, it is. And if you don't believe me, look, here's 1, 2, 3. There's it. There it is at 3. Here's 1, 2, 3, 4, 5. There it is at -5. So all the values do come out the way they're supposed to. Well, okay, now I got a couple more questions here to put forward to you here. Let's do a summary first, and then I'll put a couple more questions your way, and let's see what happens. You'll notice in the summary right here it says vertical translation. Translation means keeping the same meaning. So in other words, it's the same width, we're just moving it that way or that way. Vertical means up and down, okay? All right, so that becomes really important. So when we're in the shape of this, y equals to x squared plus q, okay? Why do I pick q? You'll see in a minute. But x squared plus q, that means I'm going to translate this up or down okay, based on the sign. So if this is positive, it goes up. If this is negative, it goes down. Very important to notice that. And you can play around with this. I suggest you go out and boot up the calculator here and start playing around with the values that you have, because I think it's kind of neat to see. I can actually go to my next value here and I can boot this down. Let's go to this. And I'm going to say, okay, how about x squared minus 10? Why not? Okay. Oops, I got x to the minus 1. Let me get rid of that guy. Okay. Whoops. Whoa. Hey, I really messed things up. There we go. X squared to the minus 10. Wow, it just doesn't want to play right. There we go. Okay, graph. And look at this. There's the minus 10. And you can count. It's all the way at the bottom of our screen. And we know, because this is set up at Zoom Standard, that is 10 all the way down at the bottom of our screen. I suggest you turn around and you try a couple more, and it makes a really, really interesting pattern on your calculator, that's for sure.